everyone, and welcome to week 7. We're going to be talking about R and how to do the same simple graphs, work with the in the R environment, creating the simple graphs and descriptive statistics. But before getting to the R environment, I just want to make sure to remind you some reviews over here. Make sure to review what we did last week. So last week we had a um, we learned how to prepare and deliver our analysis. So this slide set just reviews all of that content, how to collect the data, what the next step is to clean the data and prepare the data before we start the analysis, and then we do the analysis by transforming, visualizing, and modeling the data until we could answer these questions: that what happened, who was involved, when and where it happened, why or how it happened. And when we understand the story or the answer to our research question, we're gonna go to the next step and communicate, which we did last session. And for the communication, we can either communicate in writing format or in the presentation. And here are some important points about preparing those presentations that you did last week in your groups. Then you are supposed to go over data camp and complete the assignment under the name of the introduction to tidyverse. And you probably are ready for starting working with R Studio today. And one more thing that you must review is, as I mentioned in the first week of the class, we're going to refer to a lot of the topics that you have learned in your statistics course. So in this class, we're not learning the statistics topics. That is something that you must review in your statistics course. And here I have shared a video with you. So either refer to your own notes and material from your statistics course that you have had before, or you can just take a look at this video over here, and it helps you to review the topics. Okay, let's go to lab 5. In the lab 5, we're gonna be loading some flat files, these two files, into the RStudio environment. And then we're gonna use some functions and some packages in that environment to do our analysis, to prepare some graphs and descriptive statistics. For example, we're going to use select, filter, group by, and summarize verbs to estimate simple descriptive statistics for variables and subsets of observations. And then we're going to use ggplot to create bar plots, histogram, and scatter plot. So first, make sure to download these two files. I have already downloaded them. So after you download these, click on this link over here to join the RStudio project environment, in which we're gonna just have step-by-step instructions to prepare the graphs and descriptive statistics. When you click on this link join, it's gonna ask you to either sign up or sign in or log in into this environment that you see on my end. So when you are signing up, make sure to use your UWL email and your complete name. If you do not use your complete name, I will not be able to grade you because these are, I'm going to be able to see your code, your work over there, and I will be able to just grade your work based on that, just the same as we did earlier in the lab environment in the other previous labs. Okay, we're gonna discuss more about that later, but let's start this lab 5. You're gonna click on that lab 5 link over there. You're gonna see an environment like this, that you have lots of files over here. What this environment is, this is RStudio. this pane, if I click on one of these, let's start from the objective one. If I click on this objective one, RMD, this is a R Markdown document, and in the lower right hand corner, you have several tabs over here that the active one is files. We're gonna learn about the rest, and these files just contain some stuff that some steps that we're gonna follow today. And we're gonna start from the objective one. So click on the objective one, and you're gonna have this new window pop up over here on the upper left corner. Make sure that you download the orders data and grad data from Canvas, these two data sets, because we're going to connect them into this environment. Then in the Files lab, click on the Upload, then navigate to the location of the file. You're going to upload these files one by one. Okay, you have to do that one at a time. Give this a few seconds until it uploads them. Okay, you see that orders dataset is added among these files over here, this one that you see. Okay, let's repeat that for the grads data. We're gonna navigate to the location that grads data is located. And then you will see both datasets, both CSV files, the flat files are added here. Then to work with those data sets, we're gonna go back to this objective one, our markdown file over here. It's gonna, you're gonna see this yellow warning pop-up that it's recommending you to install some packages. So click on the install and give it a few minutes to install it. After it is installed, you will go back to this console. Okay, so if I click on this background job, you will see all of those red lines. Don't worry about the red color over there. It was just installing the packages that we're gonna need, and it's already installed. So let's go back to the console. This is the area. The console area is where we are gonna where we can type our codes, but we're gonna be working with these our markdowns that we have here. Okay, so this gray area that you see, this is called as code chunk. This chunk below this one, this in the lines of 24, 25, 26 contains the code that we're gonna run, and we have some other code chunks later in this file, in this markdown, and in other objective files that we're gonna be working. So just this area is actually the place that we are going to type our codes, just like what you did in the data camp. It is exactly the same. Okay, you were typing some code in the data camp and getting the results. This is going to be exactly the same. We're going to type our codes inside this gray area that is called as code chunk. So click on the, if you click on this gray button over here in the upper right hand corner, or if you just place your cursor inside this gray code chunk area and type Control Shift Enter, or if you are using Mac, use the Command Shift Enter on your keyboard, then you will see this line, this code chunk is going to run, execute, and anytime you see all green and no red, the chunk actually ran successfully. And if you see let me show you that. For example, if I run this, you will see this warning and this red color error over here that is telling you something is wrong in here. And if you read the details over here, you will notice what the error is. And right now the error is that I did not enter the name of the file properly to be used with this function over here. Okay, so let's just fix that. And we're gonna just type the name of the file over here, orders workbook-1.csv, whatever that your file name is here. And then if you click on this green button, or again, if you just type Control Shift Enter on your keyboard, and if you are on the Mac typing Command Shift Enter, that's going to execute this code chunk. And then you're going to see that it ran and you do not see the same warning and error again. So look in the upper right hand corner of your screen, and you will see the data is here. Okay, it is now loaded into the environment as a data frame object called orders. So we loaded this flat file inside this object, and this object is added to the environment here, and it is called as order. This object is called as order, the name that we have given to that object here. If you click on the orders, click on this blue button, blue arrow, you will see the list of all the variables that are inside this data set. If you double click on the orders, you will see this Excel-like environment. This is Excel style environment or Excel style area that you can see what is inside the data. Okay, let's go back to the objective1 file, and let's continue with our coding. Now let's try to load the grads data. We're gonna do the same, typing the grads data file name here, and Control Shift Enter is gonna run this area for me. If you want to create one of these gray code chunks, you can just click on one of these lines, and then Control Alt I is gonna insert a chunk. If you are using Mac, use Command Option I. Okay, so Command Option I or Control Alt I is going to create a new code chunk for you, and you can just start inserting the codes that you need and running that environment. Okay, I wouldn't recommend you to just type that manually. You can type it manually, but I would suggest you to use Control Alt I or Command Option I. That is faster to create it. Okay, so we are done with objective 1. Now let's get to the objective 2. So here we load the same data again. When you are in a new environment, new objective, we're gonna load it again to work with in this file. If you load the data each time, then the files can be run in any order. If you also had data preparation we needed to run, we could include that code in that chunk, or we can write it or all out in separate file and pull it into this one as a child chunk each time that we need it. So you'll see how that works later at the end of this lab. Okay, so for now, let's just load the data again with these codes. Okay, the name of the file. Let's type different here. Let's fix that. And then we're going to have data here. See, when you get a warning, you can simply just read this instruction and you will find out what the issue is. When it says no such file exists, it is probably a typo in the name of the file. Okay, I had forgotten to type these because the file names in my files includes those -1. So I entered that. Okay. So let's talk about univariate descriptive stats. In the R, it is going to be 4 steps. Now it's time to practice some of the verbs you learned in your Intro to Tidyverse course. Here are the ones we'll use most often. We're going to use select, which means to select one of the columns from the data frame. Filter means to keep observations that meet the criteria you specify. And group by means to create groups in the data, like the rows in a pivot table. It is also called slicing in other programs. And summarize means to aggregate the data using whatever function you specify. For example, mean, median, etc. Okay, let's go. Run the code below using the green play button or Control Shift Enter to create a table of average shipping cost by market from the orders data. Okay, so it means that it's gonna grab the orders data and group it by market and find the mean for this variable and give us a table. Okay, I'm sorry about that error. So the reason is that I forgot to run this earlier, uh, calling the packages. So before we start working with packages, we need to make sure that we have activated them so we can use the packages. So I'm gonna activate the library. I'm gonna activate the tidyverse, call the tidyverse package. So first we need to run this and then run the name of the run the reading of the um, files. Okay. Now it's time to practice some of the verbs that we learned earlier. So this is these are the files that verbs that we're going to use today in this lab. And the error that we just got earlier about this, it was that this action was not recognized because I forgot to run this chunk of code earlier. Okay. All right, when you run this code chunk related to creating a mean for the shipping cost, it will give you this table for the descriptive statistics. Now you try to create a new chunk below, then using the orders data frame, summarize the median shipping cost by market. To get the median, simply just replace the mean in summarize function with median. Try to pause the video and type it yourselves. So we're gonna have this. We're gonna group by market, and then we're gonna um, summarize and find the median of shipping cost. And when you run it, you will see the new table, including the median of shipping cost by the type of the market. Now let's try something tougher. This time we're gonna filter the data to keep only orders with category equal to furniture. Then we're gonna produce the median shipping cost, and we're gonna add a chunk here to do this. Okay, so in the code chunk, we're gonna have category being equal to furniture, and then we're gonna have median over here, and we're gonna have the median for that specific category. Okay. So here are our names for all the statistics we've covered that work with summarize. Note that these don't include our measures of association. Those are bivariate. So we have mean, median, interquartile range, and standard deviation as SD. This is the standard deviation. Okay, these are a little more tricky to get. A range can be computed by max minus min, and coefficient of variation can be calculated using standard deviation divided by mean. So strangely enough, there is not a built-in mode function in R. If you want to use the mode, you need to create the function yourselves, and by using this code. So we want to create a function that is called as get mode, and that function is defined just like this inside these brackets. Okay, so we are defining a function over here. Um, we're going to use this function to get the mode. Then we need to create a separate cuts of the data and get the modes one at a time for each of those cuts. Here is the most frequently shipped to country or the mode of this data in the APAC market. So we're going to have the object APAC created. So before running that chunk, let's run this earlier chunk. And we have this function get mode created over here. We define the function and we're going to refer to that whenever we need it. You see here, for example, I'm using that function to find the mode for APAC countries, giving me the country with highest frequency. Okay. So let's run this, and Australia is the country with the highest, the most frequency over there. Now let's repeat that to get the mode for the EMEA. So we're gonna filter the market by EMEA, and then we're gonna use the get mode function that we just created. Okay, and finding the mode in that area, which is France among the EMEA countries. Okay. So we are done with objective 2. Let's go over objective 3. And in the objective 3, make sure to run this first code over here. And then make sure to fix the name of these if you want to run this code separately. But as we are following the previous one in objective 1 and 2, we have already loaded these data sets. We don't need to do that. So let's just work with the bivariate statistics. Again, we're going to have 4 steps. First, let's make a cross tabulation of market and category using the orders data. To do this, we have to use the base R syntax of telling R where to find the variable. That syntax goes data frame name and the variable name. Okay, so we're gonna run this where we have data set name and the variable name, and we are cross tabulating it with another variable in the same data set. And that's gonna give us the table that includes the cross tabulation of the orders data over there. In the next step, we're gonna have the table, this above table. This one here, this gives us the counts, but what if we want to get the percentages instead of count? So we're gonna run each chunk below and determine which code gives you the percentages of the rows, which gives you the percentage of columns, and which one gives the percentage in the entire observations that we have. Okay, so this one is going to give us the percentage of each category, for example, furniture in the APAC compared to all the data is only 4%. Let's run the percentage of the row total. This is going to give us the percentage of the furniture APAC among all the observations that we have in these 4 categories for all of the furniture category. Okay, so these numbers is the percentage out of the furniture category in total row. And this one is going to give us the percentage of the furniture among the APAC category. Okay, and the percentage of the column total. Okay, so you see the difference? This one is giving us the percent of the entire table. This gives us percent of the row total when we have this 1 over here. And if we change that 1 to 2 with this code, it's going to give us the percentage of the column total. Next, we're going to calculate the correlation. Correlation also uses base notation, base R notation. Note that you can just put the method you want used in quotes and the method. Okay, you can just have the method over here. Let's run this, and it's going to give us the correlation between orders profit, between the profit and shipping cost using Pearson method. You can change that Pearson method to any other method that you want to calculate the correlation. Okay. Now add a new chunk below, a code chunk, and estimate the correlation of your own using the grads data. So let me delete these. If you want to create the chunk, you just need to use the Control Alt I or Command Option I. Okay, so here let's just have an example, try to think of some of the variables in the grad data. So what you're going to do, you can go to the grad data and look at the variables. These are the same variables that we had before. So let's try for grads. And the variable that I'm going to select, let's say um, income wage, comma, and grads. And let's use hours work. Okay, you can keep it default or use the method to be Pearson method. And when you run it, you will see the correlation over here. Next, let's run a regression. We're gonna run a regression. Regression uses different syntax than these previous ones. Okay, so here for cross tabulation, we used table. For the percentages, we used 100 times proportion for the table. Okay, if you want the entire table, you don't need to type this, but if you want out of the row total, you can type 1, and out of column total, you will type 2. For the correlation, you can type core verb over here, and you can even define the method. But with the regression, instead of these base R uh, instead of base R notations, we're gonna use this notation over here. So the function name is gonna be LM. Then we're gonna have our y variable, and then the x variable, and then defining where those variables are coming from, the data source. So earlier, for example, for the grads, we had this name of the data, the name of the variable after this dollar sign. But here for the regression, we are using another type of the notation. If I run this, it will just regress the shipping cost over profit, and we will see the intercept and the coefficient for the shipping cost. Okay. Now let's add a new chunk and estimate the regression of your own using grad data. Let's just use the same variables as before. So we're gonna have LM, and we're gonna use grad data. Let me use let me use this one and this one, the income wage, and then you're gonna have this tilde, and then your hours work, and comma, data source equal to the name of the data, and then run it, and you will see the coefficient for hours work and the income wage. Okay. All right, we are done with the objective 4. And next, we want to, oh, sorry, we are done with objective 3. And next, we're going to go to objective 4. Again, make sure if you are starting from objective 4, make sure to run these first. So you can, so you load the data. If not, if you are already following objective 1, 2, 3, they are already loaded in the environment, then you don't need to run this. Okay, now let's talk about the graphs. We're going to have 7 graphs. We're going to use ggplot, and our ggplot is very flexible, but can be tricky as you first learn it. So to help, we are going to always use this following consistent grammar to organize our ggplot codes. So we're going to have the name of the data set that we're going to refer to. For example, if I'm going to use grads or orders, so I'm going to type the name of grads over here or the name of orders, whatever that I have in the environment area. And then we're going to have our verbs over here. If I want to filter, summarize, or whatever action that I want to do, I'm going to add it over there. Do not forget this function over here, this part over here, and then we're going to go to create the graph using ggplot. And in the ggplot, we're going to have this aesthetics part that must include the x variable and y variable depending on the type of the chart that we're going to create. Then we're going to define what that geometric part is going to be like. Is it a bar chart, line chart, scatter plot, or whatever? And other options that we need are going to be added just at the end of this. So to add that to the ggplot, we always use this plus sign. If you do not use plus sign, you will use the default, and sometimes you might receive an error. So the name of the data you're going to plot will come first. If you aren't plotting the data as they stand in the existing data frame, you may have some steps in the middle, just like this. Filter, summarize, and etc. Before you call the ggplot, then you define the access variables inside the aesthetics part of the ggplot. And then finally, you give R the encoding method by specifying the geometric environment. And here are the encoding that we have covered so far in this class, and the stories we usually see them with. So to create a chart that is used with the nominal, is used for the nominal comparison or deviation, we're going to use geom column. For bar chart, we're going to have this, which shows the frequency distribution or the ranking. So this is gonna count everything. If you want to see a bar chart that has part to whole, you can use this command over here. For the y variable, you will have this part. And for the histogram, you can use simply histogram to show the distribution. For the line plot, you're going to have this line. And for the correlation, we're going to have a point estimate that is going to be a scatter plot. And if you want to have a line, a regressed line on that scatter plot, you can add this. Okay, so in the following exercise, we're going to add the x and y variables and the correct geometric needed to reproduce each of the graphs you made in Excel. So in this first code chunk, let's just type in the name of the verbs and functions and everything that we're gonna use. So we want to summarize. We want to show the average. Okay, so here we want to show the average. Let's just type mean over here. The variables that we're gonna use are um, categorical variable as x variable, region, okay, and for the y variable, let's have average profit. Then we're gonna have gem call because our goal is to create this graph over here. If I forget adding that plus sign, let's see what will happen. I will not get the graph that I want. I will get this messy graph. See? So let's just add that plus sign over here and let's rerun it. And you will see this clean, clear graph over here, average profit by each region. Okay. Next, we're gonna recreate this graph over here. Let's just see the graph at the same time so we know what variables we need to be added over there. So we're gonna have, so everything in here is correct. We need to add the variables over there. For the variables, we're gonna have quarter, but as you see, quarter is created over here in this line. This one, the first one, tells R that this variable is date variable. Then it tells R to use that to use that date variable to create a quarter variable, and then it groups by the quarter and category and summarizes, adds up all the profit for each of those categories and creates a plot for each of those categories by quarter to calculate to show the total profit that we just created. The graph that we're gonna use is a line variable. As you can see over here in this graph at the top, we are recreating this graph. Gem line. Again, if I forget the plus sign, there will be an error or a wrong type of graph. You see, it is not complete. So let's just add the plus sign over here and let's run it. And we're gonna see a clean, beautiful graph that we can use in our presentations. Okay. Okay, now let's move on to the next graph, the horizontal bar for ranking. And for that, we're gonna use this chunk over here, where we're gonna group by market. Then we're gonna add the count. We're gonna use add count, which counts the number of orders per market, and this makes the variable n, you're gonna see, and then we're gonna use ggplot. Let's fill in the static part, which is going to be market against this n variable that we created over here. Okay, so we filled in X. Um, and it's gonna reorder around it, puts the bars in order by count, and you don't need any Y over here. Okay, um, so we're gonna have geometric type to be bar, and now let's run this code, and we have the same graph as here. Okay, and we have this bar chart. Next, let's create a vertical bar. And for that, we're going to have, again, using orders data, we're going to define X based on the graph here that I want to recreate. We're going to use the sheep mode. Sheep mode. Okay. And we're going to give it correct here, the correct geometric bar. We're gonna have this, and let's run it, and we're gonna have the same graph recreated here. And the warning sign that you see here is that this is out of date in this version. You are supposed to use after stat count. I intentionally put it here so you see that if something, some code changes, as I said earlier, over the time you will learn new stuff, the codes will change, so you're going to need to update your cheat sheet. And to update that cheat sheet, you can simply just Google and see how to fix the issue or what is the newest version of the code that you need. And the warning here is going to also give you the details of that. Okay. So we got the graph. Let's move to the diverging bar. So in the diverging bar, we have we created the same graph in Excel and Tableau. We're going to do the same in our environment as well. So we're going to use the orders data. We're going to filter the data by APAC, and then we're going to group it by country. Then we're going to summarize it to find the average profit, because we want to see the loss and profit in our bars over here. Then we're gonna mutate the loss. We're gonna create a binary variable to define the colors. Okay, this creates a binary variable to define the colors. Then we're gonna assign X and Y over here. So for the X, we're gonna have countries. And for the Y variable, we're gonna have average profit, and we're gonna use loss here. Okay, it's gonna fill using the loss. Then let's define the correct geometric type. Okay, we're gonna have geom column. And then this one provides the desired colors. And then if you want to change the theme, we can change it here. I'm going to keep it as classic default. Then we can have the y-axis show values with dollar signs using this line over here. And this one removes the legend, or you can just simply change that Okay, you can add details to your graphs or remove them inside this area. You see, we are moving forward step by step. And you will have, you see the color is different. I said to keep it black and red, but I do not get the correct graph over here. And the reason is that I forgot to add a plus sign over here. So I'm gonna just add it and rerun it. And I'm gonna get the correct graph here with the names of the countries in a vertical form, and I have the titles and everything, labels for the axes and all. Let's create a scatter plot now, and for the scatter plot we're gonna use we're going to show the relationship between shipping cost and profit. So let's have x to be equal to shipping cost and y is equal to profit. And the geometric type is going to be point for the scatter plot. And I want to have that that line, that regression line over there. So let's add that with geom smooth. Method that it's going to use is lm, and that is added to the following steps for the scheme and scale, etc. So we learned that if you want to change the scale or the colors or others, we can add all those details here after we selected the geometric type. Okay, so we have this scatter plot with the regression line. Next, we're going to create a histogram. So in the histogram, we're going to use this graph. We have only x variables over here. So for the x variable, we're going to create distribution of sales. So we only have just one variable. We don't need y variable. So I assign x to be the sales variable. And as we discussed in the class, bin width matter a lot for histogram. Okay, we have lots of these bins that these histogram distributions are created based on that, and it matters a lot. And here we are explicitly telling R to use the same bins as Excel. Okay, we are giving the same numbers as Excel, though they are still not unique and they are not still quite perfect. After you get the code to run successfully with those settings, you can delete the breaks stuff in the parentheses, so you have just geometric histogram. Look at the difference and try the geom histogram when the bandwidth is equal to 100. So experiment with these other values and see what happens. So let's run this. Okay, and you will see this here. You will see exactly the same distribution, showing the same distribution as the one that we created earlier. Now let's try and see whatever that we have in the notes. Okay, so we used exactly the same values in the default of the Excel file. Now let's just remove this part and let the default for this to run, and let's see the difference. You see now the bandwidth, these bin width have changed. You see, so we're gonna try instead of this given value, I'm gonna tell R to use the bin width being equal to 100. Let's see what happens then. Now is using the bin width, the bins being exactly equal to 100 for each of those categories. Okay, for each of those frequency bars that you see. So you can see all three just next to each other. This one is using the matching bins with the Excel. This one uses the default one when we have no given amount of the bins, and then compare that when I use only the bin width being equal to 100. Okay, so you can see the difference. The bins are getting smaller. Bins for the distribution, showing more details of the distribution. If you're interested in seeing the detailed distribution of the observations, you can simply just change the bin width and see the overall distribution. Okay, now that we are done with objective 4 as well, we're gonna go ahead and need the master markdown file to compile your lab. So after this point, this is what you're gonna do for each lab assignment that we're gonna work in the R environment. We're gonna have a master R markdown file. So you're gonna have your name here. Let's say as Babai Alderlo, and then it's gonna knit all of your files into the um, PDF. So what we are gonna do after you change your name, just click on this knit button over here, knit it to PDF, and it will automatically just go over all of the objective files. Okay. Give it a second until it runs. Ignore that. It has already created your. Okay, so you have your PDF file. Oh, PDF file created over here. You can open it. Okay, you will see your name here. You have completed lab 5. All your work is going to be here, and I'm gonna see all your code in here. So let's download that and make sure to use your name, lab 5, and save it in a location that you will be able to find. So it just saved in this folder for me. And simply, I'm gonna just go to lab 5. This is what you're gonna see in your end. So if you start the assignment, do not select Office 365. Occasionally, it just sometimes crashes. I don't know why, but you're gonna just grab this PDF file that you needed, grab it and drop it in here. It will upload as a file here, then submit the assignment, and you're done with this assignment.